Question number 5. Prove the following identities where the angles involved are acute angles for which the expressions are defined. So in this problem we have 1 to 10 problems. So what they are saying, they are asking us to prove the identities here. So you can prove by taking LHS equal to RHS, or you can prove by taking the RHS and prove it to equal to LHS. So here the first problem is cosecant theta minus cot theta square equal to 1 minus cos theta divided by 1 plus cos. Consider the LHS. Cosecant theta minus cot theta whole square. Cosecant theta is 1 divided by sin theta minus cot theta is cos theta divided by sin theta square as it is. This is equals to LCM is sin theta. So this is 1 minus cos theta. Then in the next step, taking the square to the numerator and denominator separately, 1 minus cos theta whole square divided by sin square theta. 1 minus cos theta whole square as it is divided by sin square theta can be written as 1 minus cos square theta by using the identity sin square a plus cos square a equal to 1. 1 minus cos theta whole square as it is divided by, this is 1 minus cos square theta, it is same as 1 square minus cos square theta. So we can use the identity a square minus b square here. A square minus b square is a plus b into a minus b. So we can write this one as 1 plus cos theta into 1 minus cos theta. 1 minus cos theta, 1 minus cos theta cancels. So we will remain with 1 minus cos theta divided by 1 plus cos theta, which is RHS. Fifth, second problem. Cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A equal to 2 secant A. Let us solve it by considering the LHS. Cos A divided by 1 plus sin A plus 1 plus sin A divided by cos A. Take the LCM. 1 plus sin A into cos A. Cos into cos square A plus 1 plus sin A into 1 plus sin A is 1 plus sin A whole square. This is equals to cos square A plus A square plus B square plus 2 into 1 is 2 into sin A. Okay. For this bracket we are applying the identity A plus B whole square divided by 1 plus sin A into cos A as it is. We know that cos square A plus sin square A is 1. So 1 plus 1, this 1 plus cos square A plus sin square A is 1 plus 2 sin A divided by 1 plus sin A into cos A. 1 plus 1 is 2, 2 plus 2 sin A divided by 1 plus sin A into cos A. 2 common, 1 plus sin A divided by 1 plus sin A into cos A. So 1 plus sin A cancels with 1 plus sin A. Therefore, we will remain with 2 divided by cos A. 2 as it is, 1 divided by cos A is secant A, which is RHS. So this is proved. Third question, tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta equal to 1 plus secant theta into cosecant theta. Consider the LHS tan theta divided by 1 minus cot theta plus cot theta divided by 1 minus tan theta. Tan theta can be written as sin theta divided by cos theta whole divided by 1 minus cot theta is cos theta divided by sin theta plus cot theta is cos theta divided by sin theta whole divided by 1 minus sin theta divided by cos theta. This is equals to sin theta divided by cos theta as it is divided by, here the LCM is sin theta, so we will get sin theta minus cos theta here. Similarly, cos theta divided by sin theta as it is divided by cos theta LCM, so we will get cos theta minus sin theta. The next step, this sin theta gets multiplied with this sin theta and this cos theta gets multiplied with sin theta into cos theta. Similarly, this cos theta gets multiplied with cos theta and sin theta gets multiplied with cos theta minus sin theta. Therefore, sin theta into sin theta is sin square theta divided by cos theta into sin theta minus cos theta plus cos theta into cos theta is cos square theta divided by sin theta into cos theta minus sin theta. This is equals to sin square theta divided by cos theta bracket sin theta minus cos theta. So here you can see that we have sin theta minus cos theta, whereas here we have cos theta minus sin theta. From this bracket, if we take the negative sign common, this will become minus cos square theta into divided by sin theta into sin theta minus cos theta, because minus into plus will become minus, minus into minus will become plus. From these two we have sin theta minus cos theta common, so we will get sin square theta divided by cos theta minus cos square theta divided by sin theta. This is equals to 1 divided by sin theta minus cos theta, again LCM sin theta into cos theta, sin square theta into sin theta will become sin cube theta minus cos theta into cos square theta will become cos cube theta. We have an identity for a cube minus b cube, that is a cube minus b cube is equal to a minus b into bracket a square plus b square plus ab. Use that identity here to simplify the equation. So what happens, the next step is 1 divided by sin theta minus cos theta divided by sin theta cos theta. Apply the identity a minus b, sin theta minus cos theta into bracket a square sin square theta plus b square cos square theta plus a into b sin theta into cos theta. So here this sin theta into minus cos theta cancels with sin theta minus cos theta. Sin square theta plus cos square theta will become 1. Therefore, in the next step, sin square theta plus cos square theta is 1 plus sin theta cos theta divided by sin theta into cos theta. Separate the denominator, we will get 1 divided by sin theta into cos theta plus sin theta by cos theta divided by sin theta cos theta will cancel, we will get 1. 1 divided by sin theta is cosecant theta, 1 divided by cos theta is secant theta plus 1 as it is. This is equals to RHS of the given equation. You can see here. Okay. Next question number 4. 1 plus secant a divided by secant a equal to sin square a divided by 1 minus cos a. Consider the LHS 1 plus secant a divided by secant a. So here 1 plus secant a is 1 divided by cos a divided by 1 divided by cos a. So by observing the equation, we know that on the right hand side we have only sin and cos. LCM is cos a, therefore cos a plus 1 divided by cos a whole divided by 1 divided by cos a. Cos a cancel, so it is equals to cos a plus 1, which can also be written as 1 plus cos a, multiplying by 1 minus cos a dividing by 1 minus cos a. In the numerator it is same as a plus b into a minus b, therefore it is a square minus b square. 1 square is 1 cos square a divided by 1 minus cos a. 1 minus cos square a is sin square a divided by 1 minus cos a, which is RHS. Question number 5. Cos a minus sin a plus 1 divided by cos a plus sin a minus 1 equal to cosecant a plus cot a, using the identity cos square a equal to 1 plus cot square a. So they have given the hint also. By using this identity, prove this identity in the question. So consider the LHS part. LHS is cos a minus sin a plus 1 divided by cos a plus sin a minus 1. Dividing by sin a to the numerator as well as to the denominator. So we will get cos a divided by sin a minus sin a divided by sin a plus 1 divided by sin a whole divided by cos a divided by sin a plus sin a divided by sin a minus 1 divided by sin a. Then cos a divided by sin a is cot a minus sin a cancels 1 plus 1 divided by sin a is cosecant a. Similarly, cos a divided by sin a is cot a plus sin a cancel 1 minus 1 divided by sin a is cosecant A. Here, considering cot A as A and 1 minus cosecant A as B and rationalizing the denominator, multiplying and dividing by cot A minus 1 minus cosecant A. What happens in the numerator? It is A minus B into A minus B. Okay, in place of A we have cot A, in place of B we have 1 minus cosecant A. So A plus A minus B into A minus B is A minus B whole square. So A is cot A minus B is 1 minus cosecant A. Minus of minus will become plus here, whole square, divided by. In the denominator it is similar as A plus B into A minus B. Therefore A square minus B square. In place of A we have cot and in place of B we have 1 minus cosecant A. Therefore in the next step, A minus B whole square, A square plus B square plus 2AB. By doing that we got here we will apply the identity A plus B plus C whole square for the denominator, for the numerator. This is equals to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. In place of A we have cot, in place of B we have minus 1, in place of C we have cosecant A. By applying that identity we will get cot square A plus B square is minus 1 square 1 plus C square cosecant square A. So here 2AB, because B is negative we got minus 2A cot A into 1 1. So again similarly minus 2 cos A plus 2 into CA. C is cosecant A is cot A. 2 cot A cosecant A divided by cot square A minus. So here apply the A minus B whole square identity. We will get A square plus B square minus 2AB. In the next step, cot square A plus 1, it is cosecant square A. Cot square A plus 1 is cosecant square A. Therefore, cosecant square A plus cosecant square A is 2 cosecant square A plus 2 cot A cosecant A minus 2 cot A minus 2 cosecant A divided by cot square A as it is, multiply the negative sign inside the bracket, we will get minus 1 minus cosecant square A plus minus into minus plus 2 cosecant A. In the next step, cosecant 2 cosecant A is common here in these two terms. So we will get 2 cosecant A into bracket cosecant A plus cot A. Minus 2 is common here, therefore minus 2 into cot A plus cosecant A divided by cot square A minus cosecant square A minus 1 plus 2 cosecant A. Again here cosecant A plus cot A common, we will get cosecant A plus cot A into bracket 2 cosecant A minus 2 divided by cot square A minus cosecant square A is minus 1, because we have 1 plus cot square A is equal to cosecant square A. Cot square A, bring that cosecant square A towards left hand side, it becomes minus cosecant square A equal to, send this plus 1 towards right hand side, it will become minus 1. So its value is minus 1. This minus 1 plus 2 cosecant A as it is equal to cosecant A plus cot A into bracket 2 cosecant A minus 2. So here minus 1 is minus 2, 2 cosecant A, 2 cosecant A minus 2, 2 cosecant A minus 2 cancels. So remaining terms are cosecant A plus cot A, which is RHS. So this is the solution for fifth problem.